This video is for ELEC 2132 at the University of Colorado, Denver, and I'm going to be talking about the basics of how to use LTSpice in this video. So this is what the LTSpice interface looks like. I actually have a project open. This is what the blank workspace looks like. This is a picture of the Antikythera mechanism. If you want to look that up, it's just the default background. To start a new project or a new schematic, we have to go up here to the top left and click the New Schematic button. And then you'll have a blank gray workspace. So let's just put some simple resistors on the schematic right away. You can either click the Component button up here, which looks like a little AND gate in digital logic, and scroll over and select RES for resistor, and place that, and then press escape to get rid of that. Or just type the letter R on your keyboard and resistor will come up and you can place as many of them as you want. If you need to pan and zoom and look at different things, there's zoom buttons out here. I can zoom out. I typically will always use this red X, which just zooms to fit everything in the screen as well as possible, and then I zoom out from there. If you need to cut items from the screen, you use the scissors right here. If you need to copy and paste, you can use this little double piece of paper for copy, and that will create a copy of your items. Alright, so we have two resistors in our circuit right now. Resistors don't do anything on their own, so let's add a voltage source. We can scroll over and click voltage right here. There's no shortcut for the voltage source, so you have to actually go into the menu and select voltage. So now let me zoom to make this look a little bit better. Now we need to connect everything. So I'll use the wire tool to connect everything. That was the little button with the pencil and the blue line into a complete circuit. None of these components right now have any values, so I need to add values to these components. I will right click on the voltage source, and where it says DC value for the voltage, I'll just type 9 for 9 volts. The V1 right here just refers to which number voltage source that is. So if I had multiple voltage sources, this would be V1, V2, V3, etc. For resistors, I have to type in a resistance value. If I want this to be 1 kilo ohm, I can either type in 1000 or 1K. If I want the next one to be a mega ohm, I need to type in 1 MEG. If I want this to be a milliohm, I type in 1 M. Students often make the mistake of thinking that typing in 1 capital M will mean 1 meg, but there's no case sensitivity in LTSpice, so typing in 1 capital M just defaults to 1 milliohm. You have to actually type in 1 MEG to get to mega ohm. So now we can presumably simulate the behavior of the circuit. So let's add a simulation. To do that, we go up to the Simulate button at the top left of the screen, say Edit Simulation command. Now let's just say that we want to know what the node voltages and branch currents are in this circuit. So then we would scroll all the way to the right, click on DC operating point, and there is no menu for this simulation at all. You can't change anything. It's just .op. And you have to actually place the statement on the circuit like it's a circuit element in order for it to be recognized and simulated. So we place that .op there. And now let's try, well, let's save it first. Draft 3. Now let's try running it by going to Simulate and Run. Oh, we're going to get an error because I didn't place a ground in the circuit. So even though in the textbook a lot of circuits are drawn without ground, LTSpice always needs a ground. So to place a ground, you can either go up to the top and click this ground button and place it there, or you can just click G on your keyboard to get ground, and then make sure to connect it with a wire to the ground node, and now you're good to go. So now let's simulate, and we get our node voltages and branch currents. So the current through resistor 4 is 8.99 microamps. The current through all of those is the same. The current through the voltage source is minus 8.99 just because it's pointing in the opposite direction of the current through the resistors. And then the voltages at the nodes are given as 9 and 8.99 volts. Those nodes were not labeled. If we actually just take our cursor and click on the node, those voltages will come up. Perhaps a more straightforward way to see the node voltages right away is to label the nodes. So you use the label tool, which is this little signpost with an A on it. And now I can just type in any name I want. Let's just call this node 1 up here, and node 2 for the second node. And now when I run the simulation, I will get the voltage at node 1 is 9 volts, the voltage at node 2 is 8.99 volts. This can also be helpful, say, if we want to have disconnected parts of a circuit. So let's add another circuit over here on the right side. Make sure to connect everything. Let's give some values, 2K, 3.3K. And now let's connect, actually let's connect this to node 2. So now, even though I haven't drawn the wire, node 2 here and here are electrically connected because I have labeled them the same in the schematic. So now that's going to change our values. Now, voltage at node 1 is 9 volts, voltage at node 2 is 7.565 volts, and the voltage at an unlabeled node is 4.71 volts. That node is right here. So now if I run that simulation again, the voltage at node 3 is 4.71 volts. Okay, so now let's discuss a couple more complicated circuit elements. Let's say instead of having node 2 right here, I instead want to use a voltage-dependent voltage source. So a voltage-dependent voltage source in LTSpice is given by the label E. So I can place an E into the circuit. Let's make sure that the lower end is grounded. And I connect the positive node to my 2K resistor up here. Now the voltage that this source creates is dependent on is given by these two terminals right here. And so I am just going to label the negative terminal as ground and the positive terminal as node 2. Now, usually you have a gain to the voltage, and so I'm going to change the gain to 0.2. That was it automatically comes up as just having the name value when you edit that attribute of the component. And then it'll show up in the schematic as well as having value 0.2. So now let's relabel our nodes. Let's say node 3 being right here and node 4 being right here. And then we can rerun our simulation and we get values for the voltage at node 3 and node 4. This 1.7982 is going to be 0.2 of 8.991 volts. Alternatively, a voltage-dependent current source is component name G. So let's connect one of those in there. And let's give G the multiplier 2 micro. So that's 2 times 10 to the minus 6. And the prefix for micro in LTSpice is just the letter U for micro. It looks like the mu in Greek letters, but it's just U in here. So now let's simulate that again. And the voltage at node 3 now is about 95 millivolts. The voltage at node 4 is 59 millivolts. Okay, so again, just to go over some component value prefixes. For kiloohms, I would use K. For megaohms, I would use MEG. For gigaohms, I would use capital G. For milliohms, I would use M. You probably won't ever see milliohms, but you will see millifarads and millihenries. For micro, I use the letter U. For nano, I use the letter N. For pico, I use the letter P, and you'll probably never see femto, but for that you would use the letter F.